All right, guys, this is lesson 6-4. It's going to be solving systems with whichever way makes the most sense in the situation. We're going to skip this for now since I'm not there to talk you through it. But this is like real world situations with systems. So here's how you can choose which method is best, okay? Graphing you will do when you want a visual, when you need a visual representation of the information that you are using, or if you want to estimate, graphing is going to be maybe your easiest bet, just to see like, oh, if I see the graph, it looks like it's about right here. So that's graphing. We won't do graphing with this stuff today. Substitution is when one equation already has a variable isolated, so a variable by itself, right, on one side of the equal sign, or it's easy to isolate one variable. So if you can very easily move things around to get a variable by itself completely, then substitution is a good way. And then elimination is when the coefficients of one variable are the same or opposites. When they're the same, we want to make them opposites, right? So multiply one of them by -1 if they're the same thing. But ultimately, we're looking for them to be opposites. Okay. So in the real world, when this type of stuff shows up, like in a situation that it says here, when a business sells a product, the break-even point. Okay, the break-even point is when they sell enough of the product to not lose money, but not make money either. Okay, they broke even. So they didn't lose anything, but they didn't gain anything. They just broke even. Before you hit the break-even point, you are typically losing money. And after you hit the break-even point, you make money. Okay. So you can kind of see it in the picture here, right? Here's the break-even point. The solution would be your break-even point. Everything beyond that, you're making money this way. Everything the other side of that, you're losing money. Okay. So that's a big business concept, is the break-even point. All right. So if you look at example 1 here, it says a fashion designer makes and sells hats. The material for each hat costs $5.50. Okay, so that's what we are spending. The hats sell for $12.50. So that's what we're taking in. That's income. Okay, it says the designer spends $1,400 on advertising. That's money that they are spending again. How many hats must the designer sell to break even? So the income equation is saying hats sell for $12.50 per hat, okay? So we would say the cost is $12.50 per hat, okay? So I'm going to call hats X here, or the income is $12.50 per hat. The cost would be, they are spending $5.50 per hat, but they also spent $400 on advertising. So the cost equation, if you think about that, is $5.50 per hat again, but then that extra $1,400 is just a one-time spent it on advertising. So those would be your two equations, okay? Now I want you to stop and think about what makes the most sense to you in this scenario, okay? We've learned how to graph, we've learned how to do substitution, and we've learned how to do elimination. And if you think back to what we said elimination is best when you have opposite or same variables, but in standard form typically. Substitution is best when a variable has been isolated. And we actually have both of our variables isolated, right? Y is by itself. So what you can do is you can take what y equals and you can put it into the other equation. So that's what I'm going to do over here. So 1250x equals 550x plus 1400. And then we solve. So we're going to take away the 550x. So you get 7x equals 1400, because this is 0. And then we divide by 7. So x equals 200. It says how many hats must the designer sell to break even? That is your break even point. Okay, so when they have sold 200 hats, they break even. Now, if the question said, what is their income at the break-even point, then you would plug that 200, that x, into your equation. So 1250 times 200 would be $2,500. So that's their break-even amount. But the number of hats where they break even would be 200. Okay. All right, example 2. It says a stay-at-home mom opens an Etsy shop and makes sets of stationery. Supplies cost her $2 per set. Okay, cost her $2 per set. She sells the sets for $8. So $8 per set. She also pays $500 per month for childcare so she can work on her stationery. How many sets does she need to sell each month to break even? Okay. So again, you kind of want to figure this cost and income setup. I'm going to flip that so I don't confuse you. We did income first. We'll start with income and cost. It doesn't matter, okay? You can do either. So your income equation, she sells them for $8 each. So that's going to be y equals 8 times the number of stationery sets. So that's what our x is representing right now, right? The number of sets. Her cost is y equals, so $2 per set plus the $500 that she pays. And we're talking about what she needs to sell in a month. So you don't need to multiply by the number of months because we're talking about 1 month. Okay, so $500 for 1 month. So this is your setup. And again, your best bet here is substitution. We know what y equals. Take it here, drop it in. So 8x equals 2x plus 500. We're going to take away the 2x. So 6x equals 500. And then we're going to divide by 6. And 500 divided by 6 is 83.3 repeating. So her break even doesn't make a ton of sense because you're not going to sell 83 1/3 sets. So basically what this means is if she sells 83 sets, she loses money. Not a lot, but she's losing money. If she sells 84 or more, she will make money. Unless I did my math wrong, which is possible. It's been a long day. Sick kids. But that would be your setup for that. So her technical break-even point is 83 1/3, but again, not going to sell 1/3 of a set. You sell complete sets. So 83 sets or less, you lose money. 84 cents or more, you make money. Okay. Okay, look at number 3. It says the local zoo is filling 2 water tanks for the elephant exhibit. 1 water tank contains 50 gallons of water and is filled at a constant rate of 10 gallons per hour. The second water tank has 29 gallons of water and is filled at a constant rate of 3 gallons per hour. when will the two tanks have the same amount of water? Explain. Now, the first place my brain went when I saw this question was, that doesn't make sense, right? If you have 50 gallons and then you are filling at 10 gallons per hour versus 29 gallons and filling at 3 gallons per hour, it's like, when are they going to catch up to each other? They're not, right? If one starts at 29 but is only increasing by 3 gallons each hour, and the other starts at 50 and is increasing by 10 gallons each hour, it just doesn't make sense, okay? But even if you don't see that right off the bat, you could still set up equations. So tank 1, we would say y equals 50 gallons plus 10 gallons per hour, right? 10 times the number of hours, or you call it 10h if you want, 10x, however you want to think about that. So x is representing my hours right now, okay? Tank 2 would be y equals 29 gallons plus 3 gallons per hour, okay? So when will the two tanks have the same amount of water? In other words, what is their break-even point? If you solve this, oops, that's not what I want. So I'm going to take this and I'm going to substitute for y, or I'm going to take this and I'm going to substitute for that y. It doesn't matter. 50 plus 10x equal to 29 plus 3x. Okay, so it looks very similar to our other questions. But now solve it. If I take away 29, I get 21. Take away the 10x from both sides. Bring down my equal sign. So this is 0, this is 0. I get a negative 7x here. Divide by negative 7. And I get x equals negative 3. Now think about what that means. When will the two tanks have the same amount of water? You cannot have negative 3 hours. Okay, you can think of it as 3 hours ago. But you cannot have negative 3 hours. So this setup is basically saying it doesn't make sense. You can't do it. Okay, so you do need to just think about how reasonable your answer is. It is not reasonable to have negative 3 hours as your break-even point. Okay, so that is that. Look at example 4 here, and then we'll be done. A puzzle expert wrote a new Sudoku puzzle book. His initial costs are $8.64. Binding and packaging costs 80 cents a book. That's each book, right? And then the price of the book, so he sells it for $2. It says how many copies must be sold to break even. So your first equation would be y equals $864 cost plus the 80 cents per book that it costs to do the binding and packaging. Okay. Your second equation is just what you're bringing in. So $2 per book. All right. So we're going to say this replaces y. So that equals our 2x. And then we'll solve. So take away 80x. So you get 864 on the left. This goes away. $2 minus 80 cents is $1.20 times x. And then you would divide by 120. Okay, so this is 864 divided by 120. And you get 720. Okay. So it says how many copies must be sold to break even. You would have to sell 720 copies to break even. Okay, so that's the number of books. That's your X, right? If you wanted to know how much money that meant, then you would plug that 720 in here. So 2 times 720 is going to be 1440, so $1,440. So when you spend that much and bring that much in, that's your break even point. Okay, so that's what you're gonna be doing today. It's word problems. I know word problems can be a struggle at times. We are gonna spend Friday reviewing them again. Okay, so there's a worksheet to review on Friday. You don't do that now. We'll do it in class on Friday. But for now, you have like, I want to say 5 questions of homework of this. So you can get started on that, and hopefully I will see you on Friday.